All right, everyone, let's get started. Welcome back to CS 125, to my daily walkthrough. So I just want to remind everybody out there that might be joining me that this is not required. None of the many different sessions that we offer in this class are required. These are all for you if you need some extra help, if you need some extra guidance, or just want to come and hang out and see a familiar face for a few moments every day. We have, as always, a lot going on in the class. So if we go over here to the calendar page, you can see that today, where are we in the day? All right, so we're just starting my lesson overview. But this afternoon, we have a concept review that follows mine, another daily lesson overview, a new student onboarding session, an Ask Us Anything session, a daily social hour, and then 2 homework sessions in the evening. And we also started off today with a homework session at 4 a.m. for those of you in Eastern time zone. So, our idea this semester with having this class be asynchronous is really to kind of give you guys lots of different opportunities to interact with the course staff, learn the material, ask questions, and those are kind of spread out throughout the day. So there's no one place that you have to be at any given point in the day, but we give you lots of different options for ways to interact, ways to help. There is, I do read Reddit, and I was, somebody today was, I've seen this complaint many, many times. Someone was complaining, my classes are so disorganized. They've got stuff, all over the place, information about what to do all over the place, and it's hard to keep up. And all I can say is that in CS 125, that every day you have a lesson to complete. That every day you have a homework problem to do. That every week you have a quiz on the same day during lab. And so, this class has a pretty natural rhythm to it. We are giving you more flexibility this semester because, we're asynchronous, and I think that's going to work out well. But, you know what to do every day. Get up. If it's a work day, if it's a Monday through Friday, you've got CS 125 to do. Once we release the machine project, you'll need to probably allocate some time on the weekends as well to work on that. But for now, Monday through Friday, if it's a day that ends in day, as they say, you probably have something to do for this class. Just a little bit, not a huge amount, but that's kind of how we get you going. All right, so looks like we're gonna have a small group today, which is awesome. If you guys have questions, please shout them out in the chat. Or on the forum thread that we have up for this. I'm also going to keep an eye on that. So today's lesson is about conditional, sort of the building blocks of decision making in our program. So we've talked over the last couple lessons about how we store data in our program and how we manipulate that data. And those are sort of really important components of what computers are good at. But eventually, we want the computer to behave in a certain way. We want it to do something in response to what we did. And a lot of, the interesting behaviors that computers are capable of are founded on this ability to make decisions. And so how do we start to make decisions based on the data in our programs? And so there's two, let me get back to the lesson here. There's 2 components to this, and I want to be careful to kind of distinguish between them. One is this idea of a conditional expression. So this lesson goes into both conditional expressions and conditional statements and talks about kind of the difference between the 2 of these. So a conditional expression is something in the code that evaluates to either true or false. Conditional expressions can be used in a variety of different places. So, for example, if I look at this, let me see if I can find so here's an example in this little playground. If I look at this chunk of the code down here, so this is my variable initialization and declaration. So I'm declaring a variable named grade of type int. I'm initializing it to the result of adding 10 and 80. This is a mathematical expression that's going to evaluate to an int. A conditional expression is going to evaluate to a Boolean. So this is a conditional expression right here. And you'll see that I'm using one of the conditional operators that we introduce in the next walkthrough. And there's 6 of them that we'll talk about today. There's probably a few others lingering out there, but these are kind of the heavy hitters that you're going to use most often. And the conditional operators that we'll look at least initially, are really for comparing numeric values. So is one thing bigger than another? Is one thing equal to another? Is one thing not equal to another? Most of those, of the 6 that we look at, greater than or equal to, less than or equal to, equals to, not equal to, all 6 of those can be applied to numeric values. So if I have 2 numbers, I can test whether or not they're equal, whether or not one is bigger than the other, etc. 2 of them, equal and not equal, can also be applied to Boolean values. So I can true is equal to true, it's not equal to false. But it doesn't really make sense to compare whether one Boolean value is bigger than another. Java doesn't allow you to do that. So this chunk of this code right here is my conditional expression. Notice that it's not an entire statement. So a statement is one line of code. The conditional expression is just a little part of that statement. In this case, the conditional expression is being used on the right side of an assignment to assign the initial value of this Boolean variable good grade, which if I wanted to, I can then print out good type, right? So it's false, right? Because in this case, grade is 90. 90 is not strictly greater than 90, and so it's false. Let's make this true. If I had 10 and 81, I get 91. 91 is strictly greater than 90, and so now that conditional expression evaluates to true. So this is the starting point. Conditional expressions get used in a couple of places in the Java programming language. You can use them, as we're doing here, to assign the value of a Boolean variable. So they can be used on the right side of the assignment when what's on the left side is a Boolean variable. What is a Boolean value a literal? I don't know. I'm trying to parse that question. Is a Boolean? I mean, there are 2 Boolean values, true and false. The literal true is, so this evaluates to true in this case. The literal true is this. And so I would say no. I would say there are 2 Boolean values, true and false. And there are 2 Boolean literals, true and false. But the values aren't literals, right? Because there's so few Boolean values, maybe it's easy to get the 2 confused. But this evaluates to a Boolean value, but it's not a Boolean literal. It's a conditional expression. All right, so hopefully that clears up that question. Great question. And again, I'm not going to subsume the content of this by going through everything that you'll see in the walkthroughs and in the videos that are part of this. But Java includes a bunch of ways to test the value of either variables or variables against literals using these conditional operators. So I've got less than or equal to, greater than or equal to, equals and not equals. So that's kind of our initial set that we'll see over the next couple days. You might wonder, what if I wanted to test whether or not grade was both greater than 90 and less than 100, and we'll see how to do that tomorrow. So right now, what we're talking about is a single conditional expression. And then tomorrow's lesson, we'll talk about making things slightly more complicated and slightly more interesting by allowing us to combine the results from multiple conditional expressions together. And that allows us to essentially express arbitrary decision-making logic. So if I wanted to say, is grade between these 2 values and also even and divisible by 6 and things like that, I can test an arbitrary combination of different things together. But for now, we're looking at just one. The one thing that comes up pretty quickly at this point is the need, and this is a good chance to kind of also just drum home this idea of assignment and the assignment operator, is to distinguish between this equality conditional operator and the assignment operator. So we talked about one of the things that makes assignment confusing is that it uses this equal sign, but it's actually not testing equality, it's doing a variable assignment. So up here, for example, this is not saying that, is I equal to 10? This is assigning the value of 10 to I in this sort of right to left fashion. Now we've introduced an actual equality test as part of one of our conditional operators, this double equal sign. It highlight both of the equals, yeah. So when we use this, we're actually comparing the value of a variable against another variable or a literal, and this will evaluate to either true or false, depending on the value of the two things. It's very easy to get these mixed up when you're just getting started programming. Because your eyes are, you're looking at code for the first time, and your eyes are still getting used to the syntax, the patterns, things like this. Once you start to do this and you've done this for a while, trust me, like your brain starts to look at text differently. My wife will sometimes give me things to proofread that she's written, and one of the things that she's always annoyed about is that I'm very sensitive to white space. So if she has this habit that some people have got into where, she has a period and then she'll have like 2 or 3 or 4 or 5 spaces after the period. And that drives me nuts. But I think part of the reason, now that I'm thinking about it, that I'm so sensitive to that is I've been looking at code for so many years, and my eyes are really sensitive to that sort of thing, right? So to me, when she gives me like a paragraph of text, I see all the places where she's used, more than one space after a period, and I go through and I fix all those, and she doesn't always appreciate that. But anyway, so I mean, you once you've done this more, once you get more practice, you start with the practice we're going to give you, you get whatever number of hours you need to get to the point, your brain starts to look at text differently, and so you'll see missing semicolons like that, right? You won't be able to look at a line of code without somehow being able to know, is there a semicolon there or not, right? You'll see strange white space, you'll see missing brackets or missing braces or whatever. You'll see the difference between this equality and the assignment operator. These things will jump out at you. But when you're just getting started, your brain is used to reading English text where some of these distinctions don't matter as much. They've done studies where you can take, you guys have probably seen this before, but you can take words and you can essentially rip out a lot of the letters in them and show people the text. And your brain is just so good at seeing the shapes of words that it doesn't notice. You can find examples of this online, and actually it's very readable. You can take like all the vowels out of a piece of text, and your brain can still process it because, again, it doesn't see the individual letters anymore. It's learned to see the shapes of words and the shapes of sentences, and so it's still able to read it even if there's a lot of information that's actually missing. So anyway, you'll get there. Just give yourself more time, more practice. But for now, just keep in mind that this distinction can throw you off sometimes. Now, one of the things we've done for you to help with this, and we'll come back and look at this when we talk about conditional statements in just a minute, is the check style tool that we use that checks the formatting of your code will actually flag a few places where you can get into trouble. And that's one of the nice things about using a tool like this, is it helps you avoid these type of mistakes. I'll show you one example of that in just a minute. All right, so conditional expression. So a conditional expression is something in my code, a little chunk of it. In this case, it's really just something that uses a conditional operator, one of these less than, less than, equal to compare the value of a variable with the value of a literal or another variable. Or two literals, but I mean, when we do two literals, it's a little strange, right? So it's like, okay, I can do this. This works fine. Java will do it for me. But inside, Java's kind of like, hey, you're better than that. I know that that 100 is greater than 90. Like, you don't need me to test that for you. So this is, so now let's look at conditional statements, okay? And I'm sensitive to places in this class where, particularly if you're new to programming and you've never seen code before, there can be some kind of, there's just a few places where it's like suddenly there's an explosion of new stuff. And it's like, where did this come from, right? And this is one of those places, right? And so what I'm going to do, actually, is I'm just going to leave this up here for a minute, maybe 1 or 2 minutes. I'm going to give the dog a treat, and then we'll come back. Hey. Chooch. Treat. You want one? Oh, here he comes. Yeah, look. I got you a treat. Yeah. Feels good. All right, so hopefully you've had a chance to squint at this for a minute. There are a bunch of new things here. So let's just, go through it slowly, carefully, patiently together. Line 1 is my familiar variable declaration and initialization. We've seen this a few times this week. So this is a familiar component of this. One of the things that you should start doing when you read code is try to see things that you've seen before. Try to see the familiar parts, even if they're inside unfamiliar parts. So for example, this we've seen before. This is our friendly, somewhat inscrutable, but we kind of know what it does, way of telling the computer to print something for us, right? Display this to the consoles, right? So this is going to display the message, it's hot. Now, I don't understand why it's inside these braces and why there's some white space here over on the left, but so those are the confusing parts, but the familiar part is like, okay, there's a print statement. Same thing with this line. So this part we've just looked at. This is a conditional expression. This is going to evaluate to either true or false, depending on the value of temperature at this point in the program. So if temperature is greater than 80, this will evaluate to true. If it's less than 80, this will evaluate to false. Less than or equal to 80, this will evaluate to false. So those are the familiar parts, right? I've got a variable declaration, a conditional expression, and a print statement. What's new is this thing that has kind of wrapped itself around my conditional expression and the print statement. And this is our first example of a conditional statement. So when we talk about computers making decisions, typically what that means is that based on some data that's available in the program, the program is either going to run some code or not run that code. So the decision I'm making here is, should I run some chunk of code, some part of the program, or should I not run that part of the program? That's the most basic decision, right? So imagine, all the different things that, your computer can do, and at any given point, it's making this decision, do them or not do them. Do them requires running some code that might throw a pop-up window or turn the computer off or whatever, right? Not doing them involves just minding its own business and continuing on doing nothing. And so in this case, I've got two choices, again. So the first choice is do something. The second choice is don't do anything. So now there's a couple of things. So if we think about that, if I'm going to have the computer make a decision about what to execute, I need to tell it two pieces of information. The first is, how do you make the decision? What is the decision based on? I said the decision is based on data, but we're the programmer, and so we have to explain to the computer what data to use and how to use it. The second thing I have to explain is, what should you do if the condition is true? So if the test that I do on the data works out to be true, what's the code that I run? And that code will not be run if the condition is false. So let's go back to our syntax and go through this and look at each part. So this is something that's called an if statement. It's a conditional statement. It's the most important conditional statement, the most commonly used conditional statement. This is something that you'll see all over the place, right? This is maybe one of the most common pieces of computer code. We talked about basic computer capabilities, working with data. We've been talking about last 2 days, making decisions. This is the basis of that. Repeating things. Monday, we'll get there. So the way I tell the computer that I want to start off one of these is I use the word if. Now, if in Java is what's called a reserved word, and we'll see a couple of these. So for example, I can't have a variable called if. This code will produce an error, right? If I give it 2 Fs, then I'm fine, right? But I can't name a variable if, right? If it's reserved to indicate that I'm starting this particular type of conditional statement. So that's the first part of the conditional statement. There's 3 parts. The first part is the keyword if. The second part is between these 2 parentheses. So an if statement always starts if space, open parenthesis, stuff, close parenthesis. That's what's in here. What's in between these parentheses has to evaluate it has to be a conditional expression. So this has to evaluate to either true or false, because that's how the program is going to make the decision about whether or not to run the extra code or not. So remember I said there's two things I have to tell my code. I have to tell it how to make the decision and then what to do if the decision is true. This is how to make the decision. So in this case, what I'm telling the program is the way you make this decision is that you use the current value of temperature and you compare it with 80. If the current value of temperature is greater than 80, then I want you to execute some extra code. If it's not, don't execute that code. All right? And now, the second thing I need to do. The second thing I need to tell it was how do I indicate the code to run? So the idea is when this condition is true, the code should do something extra, right? And now what I have is I have this extra piece of syntax, and like I said, there's a lot flying in the door right now. So just hang on, and we'll get through it one character, one line at a time. I have my first block. So a block of code, this is explained a little bit more in the lesson, in the next part of the lesson, starts with a curly brace, an open curly brace, and ends with a closed curly brace. What we do to help us identify blocks of code when we're reading them is that we indent the contents by a certain amount. So all the lines inside this we're going to indent by 2 spaces. This is not required. You could get Java to run it even if you didn't indent it, but this is so important because it makes the code so much easier to read. What's inside this block can be quite a few different things. Now you can't put any Java code inside this block, but you can put a lot of the code that we've already looked at inside here. So for example, I can declare a variable and initialize it. I can print something. I can print a variable, right? In this case, I'm going to print I. I can, put another conditional statement inside here. So this block of code can contain a lot of the programming constructs that we've already seen. So again, just to review, I really want to hammer this home, particularly for those of you that have just started to program. 3 parts to the if statement. The first part is if. That's how I indicate that the statement is beginning. The second part tells Java how to make a decision about what to do. So it says, here's the basis for making this decision. The basis is this conditional expression. If temperature is greater than 80, then I'm going to execute the code inside the block. When Java executes this program, what it'll do is when it reaches this if statement, it evaluates the conditional expression in here. If it's true, it enters this block and begins executing the statements inside the block. When it's done, so it gets to line 4 and it just drops out of the block and keeps going. Okay? And so you'll see here that done is printed when this program completes. So now let's choose a value that's going to cause it not to enter the block, and we'll see that it only prints done. So what happened when I ran it this time? It got to line 2. It said, you told me to execute some extra code if temperature is greater than 80, but temperature is only 78.8. So I'm going to skip this block, which does not get executed, and I'm going to jump to the end. I jump to the end. I just continue after the block, right? So for example, I could put another if statement down here. So let's say if temperature is greater than 70, I'll say it's temperate. I can spell temperate. And now you'll see, done is in the wrong spot now, but now you'll see that I can have 2 of these back to back, right? So it just skips that block, keeps going, and continues to execute the rest of the code. So now let's talk about a block. We're going to talk more about blocks tomorrow. We talked a little bit about them just a minute ago, so maybe I won't dwell on this and get to the point where I can take some questions. But blocks set off a certain part of the program. A block starts with an open curly, ends with a closed curly. We indent the contents of the block. And there's a couple of places in our programs where we're going to use blocks. One of the places we use them is in these conditional statements, because I have to be able to tell the program what code gets executed if the condition is true. So I need some way of kind of taking that part of the program and setting it off so that I can make sure that the computer knows that this is the code to run if the condition is true. So this is what I use a block for in this case. We'll see next week when we talk about repeating parts of the program that we also use blocks to help tell the computer what part of the code should be executed multiple times. And there's a few other places that you'll see blocks. All right, so I'm going a little more slowly today than I should, so let me talk about if-else statements. So this was the last component of today's lesson. So we've looked at this if statement, and the if statement is the simplest form of conditional decision making in programs. And I want to point something out. I'm not encouraging you to do this, but you can actually get away with only writing this type of if statement in your programs and still get them to do everything you want. This is really all you need. Now again, I'm not saying to do that because it's going to make your programs really hard to write, but on some level, this is all you need, is this simple if statement. If the condition is true, run this code. Otherwise, skip that code and keep going. However, we typically have a couple of different extensions to if statements that we use that help simplify our code and make it easier to maintain. And one of them is this idea of an if-else. We'll talk about another one of these tomorrow, but this is something called an if-else statement. So you'll see, again, some new syntax here. But what parts of this do we recognize? So I see on line 1 that I've got a variable declaration and initialization. And then I get down to the closing brace on line 4, and that's all stuff that I've seen before, right? So this part is familiar to me. I've got an if statement with a conditional expression between parentheses, a block of code that starts with an open curly, closes with a closed curly, and then I drop out of that. But now I've got this new thing hanging out here, which is called the else clause. So an if statement can be followed by this else block. The else is executed if the part inside the if is not. So the way that Java interprets this is it says, if this condition is true, so if the value of temperature at this point in the program is greater than 80, execute this line of code. If it's not, execute this line of code. So now, before I was choosing between doing something or doing nothing. Now I'm choosing between doing thing A or doing thing B. So thing A is the part that's inside the first part of the if statement. Thing B is this else block. And so when the computer reaches this point in the program, it's going to do one or the other. It's always going to do just one. It's never going to do both, but it's always going to do one. It's never going to do neither. And so you'll see if I run this, and again, there's a walkthrough here that you guys should go through as well. In this case, it says it's hot. If I lower the temperature to 70, and lower the temperature to 70, not the threshold, then it says it's a nice day. So it's choosing between one of two options. Both options have a block associated with them. So this option has a block that starts here and ends here. This option has a block that starts here and ends here. The way that it's interpreted is if this conditional expression evaluates to true, I enter the first block. If it doesn't, I enter the else statement. So that's it. So that's our starting point. Now, again, I know that this was a little bit of a there's a little bit of a kind of a steep part of the learning curve here for people that are new to this, and I get that. And there'll be days like this in the class where suddenly it's like, oh gosh, I see some new things. Slow down, take a deep breath, identify things that look familiar. That's always really helpful. And then just work it out. Play with the examples, run things, try different stuff. The good news is that tomorrow we're actually going to kind of stay put. We're going to consolidate what we know about these things. We'll introduce a little of additional complexity, but not a lot. But it's really more variations on these themes that we've already introduced today. So today was kind of a couple of new big ideas. Tomorrow is some refinements of those big ideas in ways that hopefully will look familiar. All right, let me jump onto the chat. I don't see any questions on the chat. Let me go look in the lesson chat. Don't see any questions there either. I'm available to take questions at this point. So if you guys have questions about the lesson content, I'd be happy to take them. Today's homework problem, happy to talk about that. If you go through the material in the lesson, you should be really well prepared for today's homework problem, but I'm happy to take questions at this point. I know there's a little bit of delay, so I'll just kind of hang out while that sinks in. Okay, so is the default value of a Boolean variable true? Good question. Yeah. So let's find out, right? So let's take a little piece of code here. I'm going to say Boolean experiment, and I won't set a value, and then I'll try to print off that value. Okay, so this is interesting. If you notice here, what happens is that there's actually an error. So Java is actually not going to run this program. And the error says experiment might not have been initialized. So when I create a local Boolean variable, I have to give it an initial value. So for this type of Boolean variable, there is no default value. Java requires that I set it when I create. Now I can set it here, right? That'll work. I can set it to false, right? So I can use this sort of split variable declaration and initialization, or I can do it all in one line. But I can't get away with not setting a value. And that's true for all of the types of variables that we've looked at so far. So for example, if I make experiment an int, I'm going to have the same problem. So, there's no default value for a local Boolean variable. I have to assign it. You can imagine that this is this is not a bug. This is a feature of Java. So Java is essentially telling you, hey, I think this might be an error in your code. That's something that you need to fix. You didn't tell me what the initial value is. Now Java could be like, hey, I'll be helpful. I'll set a value for you, and maybe that works out and maybe it doesn't. But it's probably better to require that the programmer actually do this, right? So this is a place where Java is kind of looking out for you, right? It's saying, you know what? You should probably really set a value to that because you might want to think about what the default value should be. There are, I'm trying to think. Well, actually, just because we're here and we have a few extra minutes, I'll show you like a fun. So that's not it. Yeah. So So for the playgrounds you guys are using in the as part of the 125 website, we actually I've been involved in some of the development for that. We've been using this tool that other people posted. This is an open source project. And I made a change to this that was designed to kind of enable a certain type of functionality. The language that we're using for this is JavaScript. Okay, so JavaScript, let me try to, JavaScript and Java are two totally different languages, by the way. They have no relationship to each other, even though the names are similar. JavaScript's a totally different programming language. And in JavaScript, actually, JavaScript has this idea of something being falsy. So even, for example, like a string. So the empty string in Java will evaluate to false in a conditional expression. My On some level, I think that the language is trying to be helpful, but this also leads to strange problems. So you'll see here from my, we were just discussing this a couple weeks ago, that the change that I made to the code actually introduced a bug, which was caused by the fact that I forgot that in JavaScript, the empty string is considered false. So I'm trying to figure out if I can find a way to show you guys this. Okay, here we go. Let's see. So here's a little JavaScript playground, and I'm not expecting you guys to understand this. So let's run this. How do I run it? Oh, I guess I hit this play button. Okay, so in JavaScript, like a string. Okay, so the output is down here. In JavaScript, a string that has some data in it is considered to be true. All right. In Java, this would never work because Java would say this isn't a conditional expression. But JavaScript tries to be more helpful. And it's like, oh, well, I'm making this decision that a group of characters is falsy if it's empty, and truey if it's not. And so again, I can use this as part of a conditional expression, and you'll see if I use an empty string, I don't enter this block. Now again, this is a different language, but you guys see some of the same features here, right? So I've got a block of code, I've got an if statement, I have a conditional expression in here. It's just in JavaScript. JavaScript will evaluate lots of different things to conditional expressions, but this can turn out to be a problem, right? So again, this is sort of a place where Java being a little bit more strict about how things work is actually pretty helpful. All right, great question. Let's see here. Yes, that's what quiz covers. Is there a mathematical logic planted in Java? I mean, Java can perform these simple conditional tests, and we will talk tomorrow about how we can start to build more complex decisions out of these smaller building blocks. So you might think, again, if I wanted to test whether or not a value is between two numbers, I need to test both that it's bigger than one and smaller than the other. How can I do that? Well, I actually need to combine the result of two different conditional expressions. We'll talk about that tomorrow, right? And yes, you can do that. So Java does have this logic engine built into it that it can use to evaluate Boolean expressions. Let's see, other questions. So why Boolean? Yeah, so if I do something like Boolean x is equal to 90 to 85, let's talk about exactly what happens when this is executed. So Boolean experiment is equal to 90 greater than 85. So this is an assignment. So remember, we start with the right side of the assignment and we evaluate that first. This is a conditional expression. I've got a conditional operator, the greater than. I've got two literals. Now, again, you don't see this in code typically because somebody would just write this, right? But you can do it. So in this case, Java comes to this line. It says, I need to evaluate this conditional expression to evaluate the right side of the assignment. 90 is greater than 85, so this evaluates to true. And then I take the value of true and I store it, moving right to left, into the variable experiment. Now, the type system is going to be used here as usual. So if I try to store the result into an int, it's not going to work because I'm trying to take a Boolean and convert it to an int. If I change this to be math, then I'm okay. But if I change it to be math, then I can't store it in a Boolean. So this is a difference between these mathematical expressions, right, and our conditional expressions. The conditional expression evaluates to a Boolean value. Great, excellent questions. Let's see, anything else? I'm just going through does Java determine the results for comparisons between characters? Yeah, okay, great sort of character trivia question. I hate Java characters. We're not going to teach them anymore. But yeah, I think that's the case. Let's try it just for fun. So the question is, can I compare characters in Java? And if so, why? So let's just print the result of first less than second. Yeah, so I think that's the case. Because remember, for reasons that for no reasons, there's no reason, it's arbitrary, the capitals are first in the ASCII character code and the smaller case letters are second. So I think if I make this A, it's going to print false. Yeah, so I can compare these. Again, like the character type is just not one that I would encourage you to master because it just tends to behave in strange ways and kind of do weird things. And it's just not, once we start to talk about strings next week, we just won't touch characters again pretty much until never. But yeah, that's essentially what's happening is that when we do this type of comparison, and that's the other reason that you can add them together, right? You know, I don't know why this prints 153. I think it's what's happening is they're being converted to integers, right? So let's try this. If I add 0, yeah. So essentially, so the question is, what happens here? Why can I add two characters together? Java's converting them to integers or to integer values, and then it's completing the operation, right? So essentially, x is the character code 88, which, if we go back and look at our ASCII table, is completely correct. Number 88 is x. I should know that. I like that number. Good question. Yes, can I have a conditional expression with math? Yeah, try it. As people are saying, like, best thing is, grab a playground. I'm going to put up like a whole playground page for you guys on the site. I just haven't gotten around to that yet. But for now, like any of these playgrounds will do, right? They all work the same. So let's try this, let's try Boolean, do some math is equal to 10. Well, let's make this fun. Let's make a variable named I, make it 0 as I times I plus 10 times 20 is greater than 50, 55, whatever. And then let's print out that, do some math, and we'll see that it's true. Y, I plus 10, well, actually, let's see here. I think the order of operations here means that 10 times 20 will be evaluated first. That's 200, that ends up being 200. I can also just print just to convince myself of this. Typically, when I do stuff like this in my programs, I always put parentheses around stuff, even if I think I know how it's going to work. Yeah, so 10, well, actually, I guess in this case, it actually doesn't matter. It evaluates the same thing either way. Let's look at this. Yeah, okay, so you'll see that what's really happening is this. So the multiply has higher precedence than the addition. It gets executed first, and then I gets added. But again, if you're writing code like this, don't force people to think about it, just like put some parentheses in here. They're cheap, they're basically free. And in fact, to be honest, I would just do this. It's just so much more clear. Whenever you have a complicated, even slightly complicated expression on one side of a conditional operator, do your readers do them the solid of just put some parentheses around it so that when I'm reading it, because if I'm tired and it's late at night, right, I might not see the I over there. I might just see this, and I might miss the fact that this is being added. So anyway, I mean, how often do you see complicated math like this in a lot of computer programs? I guess it depends on what you're doing, right? But you certainly can't do this. Yeah, it's totally valid. Yeah, but the playgrounds will work. The playgrounds work perfectly. I mean, this is actually, using a real Java compiler and being executed and run. So there's no significant differences between the playground environment and an actual Java compiler that you might use. The big difference at this point in the class, which we will start to talk about in the coming weeks, is that normally Java doesn't allow you to write what's called loose code. So if I open up a Java file in Eclipse and I write something like this, it's not going to execute because it's going to complain that there's not a class and all sorts of other crap. So we've done this intentionally. We do some magic behind the scenes here in the early part of the class to help you get started, right? Because I think it's a lot easier to just think about these small pieces of code, small lines, single lines, double lines. Next week we'll start writing functions, and then eventually at some point we're going to actually get to the point where we're writing entire Java classes, which some of you don't understand, and that's totally cool. That's why you're taking this class. We will get there. But yeah, the playground environments are running actual Java code, and so there's really no meaningful differences between the playground environment and what you might be able to do using an IDE, except for the fact that the playground's a lot faster and a lot easier to use. All right, so I think that's unless there are other questions that. All right. Yes, 90 is greater than 85 is, yeah, that's so that's a logic statement, right? True or false. And when we do with integers, it's also important to understand that's strictly greater than. So a number is not strictly greater than itself. If you want to compare, if you want that, you can use greater than or equal to, which has a separate symbol for it. All right, so that's my walkthrough for today. Thanks for joining me, guys. I will be back tomorrow. Well, hold on. As always, I'm gonna go. We'll go check out today's calendar together because there's always great stuff on there. Let's see. Can you just show me today? Can I see the agenda view? There we go. Check that out. So yeah. So we just finished my lesson starting right after this. So if you still have some questions, don't stick around, or jump in the Zoom room with Blair and Bo. They're at noon. They'll go over some concepts from yesterday, and I'm sure they'll be happy to answer questions about today's lesson. There's a redux of today's lesson at 1 o'clock with Nikhil and Bo. And we have several of our first week sessions today, which are continuing. So if you're just joining the class and get a little confused about how to get up and running, we've got our new student onboarding session at 2. That's with Long and David Rubinsky, both fantastic. Ask Us Anything at 3 o'clock with David. A social hour at 4 o'clock with Lou and Rohan. And then 2 homework sessions, our first one at 5 with Mira and Anisha, and a second one at 8 with Surat and Chenki. So always a fun day in CS 125. Some of you that are just joining the class, please catch up. Finish the homeworks from earlier in the week. Those are all due in a couple weeks, but there's no reason to get behind at this point. Just mop them up. They're not hard. And if you're struggling, ask for help, right? It's important to get into a rhythm with the class now in terms of how you approach things and doing a little bit every day, because that will pay off as we get later into the semester. So enjoy the rest of your day, everybody, and I will